So hi all, today we'll be seeing how to interface 8051 microcontroller with the LCD. Okay, so many of you have used, in your projects the LCD screen. You might have used in your projects for interfacing LCD with the Arduino or some other boards. You might have definitely used this display. So today's class we are going to learn how to control the LCD display with 8051 microcontroller. As we all know, microcontrollers are used to communicate information to the user. Okay. Uh, in this class, we'll be seeing one type of communication, which is through output display. Okay, LCD is a very popular output display device. Okay, at the end of this lecture, we'll be learning the hardware settings of LCD, how to interface microcontroller 8051 microcontroller with LCD, how to program 8051 microcontroller when it is connected to LCD. Okay, we are going to display some messages in the LCD from 8051 microcontroller. Okay, so where it is actually used in our day-to-day life, we have come across many displays. Okay, so the watch I'm using, the watch which I'm using, fitness watches which I'm using. So these watches display a number with full graphical interfaces. Yes, so this does not use LCD. Okay, this uses OLED display. There are a variety of display units, output display units, LEDs, OLEDs, LCDs of that sort. You need to know which type of display devices you are looking at. Okay, so this watch we are seeing, it uses more type of graphics, color, etc. So this having some advanced features called OLED, but the basic and most popular one is LCD display. So where you have seen LCD display? Okay, so first of all, look at the image. This you have seen, this is a smart digital watch. The display used here is an LCD display. Okay, this we are using regularly in our day-to-day life. And the next thing, you people are using it very regularly, calculator. The display 1, 2, 3, right? The display is nothing but LCD display. It is controlled by an output LCD display unit. And this is very commonly in our day-to-day life, we'll see this commonly, we'll come across this commonly. In a petrol bunk, the quantity and the amount of all the data will be displayed in the LCD. The screen used here is an LCD display. In the lift, we'll be changing floors. The display used here is an LCD display. The regularly we'll be checking weights in hospitals, and moreover, we all have in our home, maybe that uses an LCD display. These are very few examples I have shown, and you can imagine how many, you can imagine now how popular this LCD display or even used nowadays. Yes, can you guess? So you can think of, can you give some examples? You people can think of some examples which are daily BP machine, sugar checking, diabetic machine, everything carry an LCD display with us. Yes, washing machine timer, washing machine will set the timer, microwave oven will set the timer. Okay, nowadays AC remotes, fancy AC remotes have a display. Those everything have an LCD display in it. Okay, so by now you will understand the importance of an LCD display, why you want to know, and how the importance of programming an LCD, you might have known. Okay, this is the motivation of our class. Okay, so now we'll straight away go to the display which we are going to program, the basic display which we are going to program in 8051 microcontroller. So this display on the right hand side, you can see a display. This is the thing you might have used in your projects. Okay, this is a plain LCD. It is a character LCD. This displays only characters. Okay, 1, 2, 3, 4 numbers and characters it will display. Okay, so this LCD is a flat panel display. It will be flat and is most popularly used. The full form of LCD is liquid crystal display. Liquid crystal display. This particular LCD, which I am showing it to you now, uses a 16:2 character display. LCD. Okay, 16:2 means it has 16 columns. Okay, it has 16 columns. Let me annotate. Hope you can see the annotation here. My red color cursor mark. Okay, so it uses 16:2. Look at the diagram. So 16 means 1, 2, 3, 4, and so on till 16. So 16 columns it will have, and 2 rows. First line and second line, 2 rows and 16 columns. Understood? So first line, you can display 16 characters. Second line, you can display 16 characters. This is 16 by 2 LCD. Understood? So similar to this, you have n number of LCDs like 20 by 4, like that type of LCDs are also available. Based on the application we use, we choose the display. Okay. So this is the basic display. So we are going to discuss about this display. So this is a 16 by 2 LCD display. Okay, this is the one which we are going to interface with 8051 microcontroller. And each character you see here, T, H, I, S, single characters which you are seeing here, these characters are in 5x8 dot matrix display. It is 5x8 matrix means, look at the A here. Below, I have displayed the characters A, B, C, D. Like if you look at the display, the letter A, how it is seen? In column wise, it have 5 columns. 1, 2, 3, 4, and 5. 5 columns. And row wise, it have 8 rows, which means 1, 2, 3, 4, 5, 6, 7, 8. 8 rows will be there. So 5x7. 5x7. Yes, 5x7 dot matrix. Okay, 5x7 dot matrix. This is. So in the B, you can see 1, 2, 3, 4, 5, 6, 7 rows and 1, 2, 3, 4, 5 columns. 5x7 dot matrix. There is an error in the PPT slide. It is not 5x8, it is 5x7. Okay. So 5x7 dot matrix display is used here. To display T, it uses 5x7. To display H, it uses 5x7. Both capital letter and small letter, it can be displayed in 5x7 matrix. Understood? The takeaway from this slide is we use 16 by 2 LCD display, 16 columns and 2 rows. 2 rows means 2 lines. In each line, we can write 16 characters. That is the first point. Next point is each character is displayed in 5x7 dot matrix display. Like okay. The most popularly used LCD is 16 by 2 LCD. Understood? So next slide. Okay. Yes. So this is the pin description. This is how the LCD looks. Okay. This is the pin description. And after seeing this pin description, we'll interface this pin with 8051 microcontroller. Okay. So basically, whatever hardware devices we use, we will have a power supply. We should have some pin to power supply. Okay. And we should have a pin to ground. Okay. So power supply means this 16 by 2 LCD will consume 5 volt power. Okay. 5 volt power. So VSS, it stands for ground. You have to pin number 1 is VSS, it stands for ground. Let me annotate. Pin number 1 is VSS, it should be connected to the ground. And pin number 2 is VDD, which should be connected to 5 volt power supply. Okay. So 5 volt power supply and VSS is ground. Okay. So sometimes before lectures, we might have seen instead of VDD, it will be VCC. Okay. And ground, like so the terminologies will be different for each devices, but the concept is same. VDD should be connected to plus 5 volt and VSS should be connected to ground. First 2 pins clear, everyone? Yes. Third pin is VEE. VEE is for contrast adjustment. As this is a display unit, we need to adjust the contrast. Okay. So VEE will be connected to a variable potentiometer. Okay. 0 to 5 volt potentiometer. If the potentiometer is turned off to 0, no display. That means it is less contrast, so we cannot see anything. Okay. And when you increase VEE potentiometer level to 3 volt, 4 volt, 5 volt, the contrast will be more. Sometimes you might have experienced when you do your projects, when you connect your Arduino board with LCD display, you might have seen all the connections and programming, everything will be correct, but you will not see anything on the display. That time, the VEE you have to adjust. Maybe the contrast may be low. This is one particular mistake you do in your projects. So this you can try. The third pin is connected to the VEE, which is contrast adjustment, which will be connected via potentiometer, variable potentiometer. Okay. So next 3 pins are very important pins. But after understanding this only, we can write the programs. Okay. The pins are, first one is RS. RS stands for register select. RS stands for register select. Okay. RW stands for read and write. E stands for enable. Okay. Basically, in an LCD, there are 2 types of registers. 2 registers are present. 8-bit registers are present. One register is command register and another register is data register. Okay. So in previous slides, I have shown you some of the examples of LCD where they have used LCD, right? So in one, maybe first when you take a smart digital watch, it have used in one part they have displayed time, hour and minutes, and another part on the top they have displayed the date. On another part they have displayed the weather. On another left hand side they have customized according to the screen. Yes, we can customize the display. You display from first line itself, you start giving the characters. In the second line bottom, you have to display the data. Likewise, you can customize the way you want to look your characters to display. Yes. So in order to customize that, we have to give the commands to LCD. Commands means you are telling the LCD to display the character on the first line. You are telling the LCD to display the character on the bottom right corner, last. You are telling the LCD to start the character printing from the third line. Okay. Likewise, you want to instruct the LCD, give commands to the LCD. These commands, giving commands, okay, will be carried out through command register in the LCD. Okay, command register. Another register is data register. Data register holds the actual data. Actual data means now the time is 9:58. The 9:58 time should be displayed. Okay, that is the actual data. When I want to display a hi message, hi, this is Banupriya, like, okay, H, I have to give data. I have to give I am. I have to give M, I have to give. That is the actual data. So command register is different, data register is different. Command register holds the commands which user tells to the LCD, and data register carries the data which is the actual data to be displayed in the LCD. Can you differentiate both command register and data register? Yes. So RS is used for register select, which means whether you are giving commands or whether you are giving data. First, we need to set in RS register. Okay. So if RS, okay, I'll tell you if you give which value will make it a command register, which value will make it as data register. I'll tell you later. Next is read write. So read write is used for reading and writing the data. So whenever all the data which you give to the LCD, all the data which you give to the LCD data will be written in the LCD. Okay. And all the commands which you tell to the LCD, that is also writing to the LCD. All these are writing. Reading from the LCD is, there is an option called busy flag. Note down this point, it is very important. Busy flag checking. Not every time my LCD will be ready to display, ready to carry out the operations which a microcontroller will tell. Not every time. LCD will be busy, it's displaying some other things as well. So if you keep on sending commands or data to the LCD screen, LCD cannot print, LCD cannot display. LCD may be busy. So there is a busy flag. There is a concept called busy flag checking that we will see in another lecture. So busy flag checking. So we want to check whether the LCD is ready to receive the data or not. That is busy flag checking. So the busy flag checking will happen on the LCD because we are checking the LCD. So by that time, we use a read operation. Read operation is, we are reading the busy flag. That is called read operation. Write operation means we are displaying the data or we are displaying the commands, giving the commands to the LCD. So moreover, we will be using only the write operation. So every time read should be equal to 1 if you want to write. Okay, RW pin should be equal to 1 if you want to perform read operation. Sorry, if you want to perform read operation. R bar W equal to 0 if you want to perform write operation. So these two things you have to remember. Next is enable E pin. I'll explain the enable signal later shortly. So E stands for enable pin. So whenever you send a command, you have to enable it. Only then the command which you send will be latched to the LCD. Whenever you send a data, after sending the data, you have to enable, okay, you have to enable this pin. How you should enable, I'll tell you shortly. After that, this data will be entered into the LCD screen. So likewise, we will be enabling the Likewise, we'll be enabling the data and commands to the LCD screen. Okay. Right. Enable signal is completed. Next is data pin. Okay. So actual data or actual commands. I told you before itself, command and data are 8-bit registers. So 8 bits of data should be given. 8 bits of command should be given. So command, I'm telling you, no, start printing, start displaying from the first line, start displaying the character from the second line. So each will have a hexadecimal command. Okay. 8-bit command it will be having. Say, for example, I'll show you the commands also next slide. So it will have 8 bits data that you have to give. So for that, you have D0 to D7, 8 bits. From in that 8 bits, you can give the data or commands. Okay. This is enough. This is enough. Pin description is over. Now, next slide, how we can interface this LCD pins with the 8051 microcontroller. That is the next thing we are going to see. Okay. So see the diagram on the left hand side. So blue box shows the 8051 microcontroller. Blue box shows the 8051 microcontroller. See here, this, okay. So this rectangle shows the 8051 microcontroller and the pins related to this. And this rectangle, small rectangle, shows you the LCD display. And these pins we have discussed already. So what are the pins in the LCD? We'll recall again. VCC or VDD, which is used for plus 5 volt power supply. VSS, which is used for VEE or otherwise VEE. VSS, that is used for ground, and VEE is used for display adjustment, contrast adjustment. Okay, that is connected to the 10K potentiometer, and VCC to plus 5 volt and VSS to the ground. This connection is clear, everyone? Very simple. Yes. And we have 3 pins, I told you, RS, RWE, and we have 8 pins D0 to D7 for latching your data or command to the 8051 from 8051 microcontroller. We have to send it to LCD. So for that purpose, D0 to D7 is present. So what will happen is these pins will be connected. I have told you before itself, all the external devices, whatever we connect externally to the microcontroller will be connected by using the port. By using port only, you can connect your external device with the microcontroller. So we have 4 ports in 8051 that we have discussed previously. Port 1, port 2, port 0, and port 3. In this port 1, we are using port 1, 1.0 to 1.7. We have connected with D0 to D7. This is not like you have to every time you should use 1.01 port 1 like. You can use port 2, port 0, port 3 as well. Okay. In this example, they have connected to port 1. So D0 is connected to port 1.0. D1 will be connected to port 1.1, 1.2, so on till port 1.7. Okay. So next RS, RWE. So this also should be connected to the port. Only then you can control them. Okay. So RS is connected to port 2.0. RW is connected to port 2.1. E is connected to port 2.2. And this also, you can use any ports. Here they have used port 2 for this operation. Okay. So clear? This is the interfacing diagram of LCD with the 8051 microcontroller. Okay. So I discussed you about comments, giving comments. Okay. Giving data is different. Giving data means if I want to send a hi message, H is a data. I can give directly H to the microcontroller. Okay. Hexadecimal value. I can give directly. Banupriya, B, I can give directly. A, I can give directly. Numbers 1, 2, 3, I can give directly to the microcontroller. Data is different, but comments, the manufacturer of LCD display itself, they have given a data sheet wherein they carry this hexadecimal codes for the particular commands. So look at the command to the LCD. This is the command you want to give to the LCD. Clear display screen. Okay. Clear display screen means LCD will be cleared. Okay. That code is 1. 1 is not decimal 1. This is hexadecimal 1, which means 0 by 0, 1. So in that 8 bits, means 8 bits you have to give 0, 0, 0, 0, 0, 0, 0, 1. 8 bits you have to give in D0 to D7. Select the command register. Select it to command register. Give the data 0, 0, 0, 0, 0, 0, 0, 1. Okay. When the microcontroller gives this, it will clear the display screen. Next, for example, what can I say? look at the example 80H, okay, 80. 80 is a hexadecimal number. 8 bits, how will you write in 8421 codes? 10000000. So this 80, what is the instruction for that hexadecimal value? Force the cursor to the beginning of the first line. So first line, okay. Beginning of the second line means C0, okay. Likewise, commands are given. So this commands in hexadecimal numbers, we have to give from 8051 microcontroller to LCD. The LCD will understand, oh, this is a command. We should process accordingly. Okay, right? So these are the commands. You don't want to by heart all the commands. Just remember the commands, 4, 5 commands. You just remember in order to write a program. Okay. So next. I'll tell you, we already discussed the data register and command register, right? So in this, one thing you remember, okay? I'll write down here. In this, RS equal to 1 means it will select data register. RS equal to 1 means it will select data register. RS equal to 0 means it will select command register. RS equal to 0 means it will select command register. First, we need to select which register. Then only when you send, if I send 80H, okay, it will not consider as a data. It should consider as a command. I'll think I'm sending a command. But if you don't select the command register, your LCD will think it is a data and display the data 80H in the LCD display screen. Can you understand now? So this is very important. So in this slide, the only thing to remember is this point. When RS equal to 1, data register. When RS equal to 0, it is command register. You have to send 0 and 1 to the RS register. Okay. Next. I'll erase this. Next is read write. We have seen already. When RW equal to 1, it is read operation. When RW equal to 0, it is write operation. Enable pin. This I want to tell you. Okay. Enable. How you will enable your command as well as data is you have to give a high to low pulse on that particular pin. High pulse, then low pulse, which means you have to first give a 1. After that, you have to give a 0 with some delay. That is high to low pulse. Okay. High means 1, low means 0. In high, it should stay for some time. So introduce a delay. In low, it should stay for some time. So introduce a delay. So if you give E equal to 1 and E equal to 0, then your command or data, whichever you are sending, will be latched to the LCD. Okay. This you have to understand. High to low pulse. And I have mentioned the width of the pulse also. It should be 450 nanosecond width. Okay, the width of the pulse. Okay. So next is the data pins. This we have already explained. So instruction command codes like clear the display, force the cursor to the home position, blink the cursor, etc. This also we have discussed. Okay. So with this, the introduction of LCD and how to interface with LCD with the 8051 microcontroller is the configurations, everything over. In next lecture, we will be seeing how to program the LCD. Okay. So that's from my side for today's lecture. And I hope you understood this. And next lecture, we'll be seeing how to write programming. After interfacing, how to write programming. We'll be writing embedded C program for interfacing 8051 microcontroller with LCD. Okay, thank you. Have a good day.